Hello everybody, welcome again to my YouTube channel. This time I'm making a small tray what is sitting on the electric control box of the cacao machine. You will see some nice tips and tricks, certainly for those who are searching a CNC machine. It could be interesting. So here we are again. As you can see, I designed my small cabinet what is sitting on the electric control box of the cacao machine, CNC cacao machine, in SketchUp. It is with a small tray to put my mills in and a second small tray just to put my tools on. If you design it in SketchUp, it's good that you know from the beginning on to work with different layers. Then you have afterwards less work if you import it in a VCarve software. So I put everything in a separate layer. One layer, the most important layer, is then the layer that I want to mill. So you can easily see this is the part I don't want to mill. That's the box, the original box, and then the second layer is everything what are hinges or measurements. That's also something I don't want to mill. If this is done, then you can save the file as a SketchUp file, and afterwards you can go to Vectric, open Vectric. Let's do it again as I started. So the first thing you have to do is create a new file. Then you can give in the measurements of the plywood that you want to use. So for example, the first plywood I found, it are all pieces that I have, waste pieces that I could use to make this cabinet. So the first one is 900 on 910. And the thickness is 12. Okay, that's done. I will add all the other parts that I found as waste parts, but useful to make this cabinet. I'm not gonna annoy you to how I add all those other pieces, but I will explain you how it works. Because that's very nice to see. So that's done. You can see now all the plywoods that I added into the VCarve program, the Vectric program. It's quite easy to add a new one. Just click on add, give it a name, for example, black. And to remember afterwards which plate you have in front of you, you just add also, for example, the thickness. And this is the fifth plate, for example. Then you can adjust the measurements, for example, 1 meter on 1 meter 50, for example. Oh, like this, and 18 thick. Okay, so you see now all the plates. If I go to design and I look to all the plates I have now the names of the plates, and the plate that is activated is white and the other ones are in gray. So if you now, for example, design rectangle, and you just want it to move it to another plate. For example, this one has to be cut in a 12mm thick plate. You just select that right mouse button and then say move it to sheet 12 here, white 12 up, and it's done. It was better not only to move but replace it, but anyway, you know you understand the picture. So let's now add, first let's throw this away, up. Let's now add the design, what we made in SketchUp, import vectors, go to the right place where I saved the file, here, and it was this one. Open it. You get now a small wizard, and as you remember, it was important to put everything in different layers and certainly use a separate layer where a separate layer where is everything in it that you want to cut. So you can then say that's the only layer what I want to import. You get more information here, as example, how much place you want to have between plates to get your drill between it, and other things what is now for my design less important, but things that are important to get a right design into Vectric if you import it from SketchUp. For example, you know or you don't know, but I tell you that SketchUp is working with polygons and not with real circles. Here the circles will be changed, the polygons will be changed in real circles, for example. But that's not the case for us because everything is square. Let's import it. Let's do the importation. Voila, here you see it. Everything is on this plate, and now you can easily say, no, I want, for example, this one to another plate because it is on the black one, and I want it to a white one. Which white one? The white one 18, for example. There it is. That I can throw away, and further on I can now move all the parts to the right space as it has to be done. I'm not gonna annoy you with that because it's taking a little bit too long, but I will show the results and the work what I did afterwards before I can start milling. It is not that way that you can, for example, design in SketchUp, just import it in this case Cut2 Pro, and directly start milling. No, there are a few things to do. I'm gonna show you. So everything is beautiful organized now on the correct plates. Let me show you. You can see here everything what has to be cut in the plate of 12 millimeters thick. The black plate, the two black plates, the white one 80 millimeters thick. That's my draw. So that's well organized. That's not the only thing what you have to do. You can design beautiful things in SketchUp. You can import it. 99% is correct, but there are still some things to do. For example, if everything is imported, then you will see if you start cutting that this is, as example, the three plates, left, right, and back plate. In that plate, I made a groove. In that groove will fit this part. Let me show you, just a second. This part, that's a shelf with a small lip on it. And that lip, I will show you, just a second. So this is that shelf, and you can see that that is the full thickness of the plate, and this lip that will fit beautiful in this groove. In this groove. It's easy to understand if I now start milling this with a round mill, that round mill will go to here in the original design, then go over there and go back. Of course, a round mill can't cut in corners, so you will have some debris here and here, here and here. It will be annoying if you want to assemble afterwards everything, because then you have all those small wooden parts that shouldn't be there. Similar here, let me show you. Yes, it's on this part. So you can see here, there you see it clearly. Okay. You can see that the mill is going until there, but this will be a leftover, similar as we had here with the round mill. And if you're just cutting until this corner, that will annoy you. So I designed that a little bit longer. Afterwards, this will be cut out, and then I have a beautiful 45 degrees chamfer without debris. You can see also that in the pre-design, and that's the nice thing about the software from Vectric, that you can check everything before you start milling. You can see that my mill is a little bit too small, my 45 degree mill. So that's the reason why I milling this in 2 steps. I don't know if you can see this. So the mill is going 3 times over here, then go a little bit more to the right, and then milling deeper also 3 times. And in the 45 degree mill, this will be beautiful in one line, but you can see here that I have still a leftover, so I have to adapt this. Let me show you how you can calculate this so that you can, with a small mill, my mill is too small, that's clear, because if I had a big mill, then I could cut this in one time. That's not the case. It's too small, so I have to do it in 2 steps. Let me show you how you have to do this. It's not the end of the world calculation, but there are a few things to know. So I quickly made the design in PowerPoint to explain you. Imagine that this is your plate. It's 18 millimeter thick. The software is telling you that this is 0 and this is 18. So this is the 0 point, this is the 18 point of the Vectric software, of the top point of your plate. If you choose in your setup that the top of the plate is your 0 point. So let's start thinking. I want a chamfer here of 45 degrees. My mill is too small to do it in one cut, so I have to do it in 2 trenches. The first trench will be, of course, the upper trench, because otherwise the mill will go much too deep, drilling into a small groove. So it makes sense to do this first. So what I have to do, if my mill is 45 degrees, let me throw this away for a second, but you can see what I meant. So I have to calculate from this side to that 8 millimeters, for example, and 8 millimeters deep. So 0 point will be, start depth will be 0, and cutting depth will be 8. And the line that I have to design around my plate will be 8 millimeters of the inside of the end edge of my plate. That's the first thing I have to cut. If that's done, let me put this in white that you can imagine this a little bit easier. Where is white here? Up. White, voila. Now it is cut. The second thing to do is, of course, cut the second trench, what is a little bit deeper. I don't have to go now with my mill from here difficult deeper, because a part of the wood is already cut away. So I can start directly a little bit deeper. For example, instead of starting here, because a big part is already cut away, I can start, let's say, here. Okay, let me put this on top, that it is a little bit clear what I meant. Well, I can start here, so I don't cut that much of wood away in one trench. That's okay. This is the trench that I will cut afterwards away if everything is cut out with a 6 millimeter, for example, cutter, and I will cut the completely tour out of the outside line of my plate. So first cut to do, that's done, 8/8. First cut to do is this cut, then I have to calculate. Again, this is my 0 point. I will start at 6 deep, yeah, and this will be my first cut at 6 deep, and then I can decide, okay, how deep do I have to cut? And you don't have to make the error to say, okay, let's cut 18 deep, because then it will be 6 and cut the depth 18, it will cut in your machine. So you have to think, start depth is 6, so that 0 will be now here, and the end cut will be 12. Together 18, so this will cut, go around, cut, go around, and the end cut will be here. And you have a beautiful chamfer, what will be cut out at 45 degrees with a small mill. I'm going to show you that on the plate here. As you can see, so as you can see here, you see the two trenches. The first one is the inner side. The inner side, if I go check this, it will start depth. It will start at the start depth 0, and it will cut 12 deep on the line. The second one, this one, final one, will then, of course, start at 4 and cut 14 deep also on the line. So together 18 deep, what is the full depth of your plate. If I, for example, make a failure and I say, okay, start at 4 and you have to cut the full plate and the plate is 18 deep, you're rather lucky because the software will tell you, hey, watch out, material is 18 thick, and if I calculate those both together, then it will be 22 deep. You will cut in your wasteboard in this case. So that's wrong. It should be 14. 14 and 4 is 18 together. Now this is correct. So another thing what I did, but with the same issue, round mill, if you're cutting a hole, a square hole, and afterwards you have to fit in this part, then of course if you have a round mill, then you can't push it in because the round mill will leave some debris in the corners. So the thing that you have to do is you can, with this tool, you can easily cut a little bit deeper in the four corners so that the both parts are fitting easy together. In this kind of matter, there are different issues that you have to check. But the nice thing is when it's done, you can make a beautiful preview before milling, and then if that's correct, you can save everything on a stick and start drilling without drilling things that are afterwards wrong. Let's put everything on a stick and go downstairs to the machine and start drilling. So here we are again at the CNC machine from Caracal. First thing what I did, I searched a piece of waste wood. It's plywood, what is more than good enough for my small cabinet what I'm building. The nice thing about CNC machines is that you easily can tell where to mill so that you don't have too much waste. As you remember in my design, I designed the small cabinet in that way that you don't have heads of the wood visible. So I made some chamfers at 45 degrees that you can fit together nicely together. So the first thing what we have to do is drilling with a 90-degree mill, the chamfers. So let's put this mill in the machine and start milling it. Let's change the mill. Clever thing to do is if you're changing a mill, then change it above the plate. If you're doing this in this corner, and sometimes if you unlock this, the mill will drop out, and if you're not lucky, it will fall on the floor, and then your mill is wasted. So first, putting the 90-degree mill in it. Of course, if you have an automatic tool changer, this is fun to do. If not, then you can see now how much time it will take. It's a calculation you have to make. Automatic tool changer is not that cheap, so it's easy to calculate if it's for you interesting to do, yes or no. A good tip is if you're putting a mill in the spindle, then put it in this way that it is in comparison with the brush a little bit correct. You know what this drill will mill. If it's very deep in the wood and you mill it very short, then it will push this brush completely flat. Not nice for the brush. In the other direction, if your mill is too low, then your brush will not touch the plywood. and it is not that clean, then so it's not the end of the world. Important how high your mill is in the spindle, but it's a little thing that you can take into account. So I know that it can be a little bit lower. Okay, that's done. Next thing to do, of course, don't forget, is putting all the axes right. So first thing to do is Z-axis. Done. The XS up, Y. I know that I can start there somewhere, a little bit further. That's a little bit the corner that I want. And up, so Z is already done. X, clear X. Y, clear Y. Everything is right now. We can start milling. So this is done. I've changed the mill, next mill. Now you really can see how long it will take because I don't have to correct the X and the A axis anymore, only the Z axis. So as I told you, first thing, put the spindle above your plate that the mill doesn't drop on the floor. You can take time now to see how long it takes to change this mill. This is the 3mm flat mill. That's almost. Let's say 30 seconds. 30 seconds, I guess, to change the mill. Only thing we have to do is measure the Z-axis. That's done. And now we can start up the second work. Hoppa! Off we go. So this is done. I've changed the mill, next mill. Now you really can see how long it will take because I don't have to correct the X and the A axis anymore, only the Z axis. So as I told you, first thing, put the spindle above your plate, that the mill doesn't drop on the floor. You can take time now to see how long it takes to change this mill. This is the 3mm flat mill. That's almost good. Let's say 30 seconds. 30 seconds, I guess, to change the mill. Only thing we have to do is measure the Z-axis. That's done. And now we can start up the second work. Hoppa! Okay, here we are again with all the parts. As you can see, parts that are a little bit bigger, you don't need to make any bridges due to that the surface is good enough for the vacuum table to tear it strong enough. and it will keep on its place during cutting. If you have small parts, I'm always a little bit afraid that it could move at the end if everything is cut. So I make some very small bridges that everything stays beautiful in place. Let's cut them out and beef the corners a little bit up and see what the result is. Okay, all the parts are cleaned up. Let's fit them together and see what we got. This should be here somewhere. In the other direction. And you can see how they fit them. So the back plate, it's so correct. It's always a pleasure to put them together. And then this one. There's even not glue in it, between it, but it is already fitting together as it is glued. And also you can see it, how it's not a joke, it's so beautiful, correct. All the corners are nice as I wanted. Let's put everything together and glue it together to see what the result will be. So this is the end result. As you can see, I made a small tray. One tray will be for the tools. I will engrave that later on, that it is beautiful fitting. My mills will come here. Don't forget, this is all very cheap material. Cheap plywood, the cheapest leftovers. But I'm satisfied. If you see how correct CNC is working, it's scary correct. Have a look. Made here my corner of 90 degrees without a header visible, so engraved in 45 degrees. You can see that this is nice fitting. That's the big advantage of CNC. To the end of this video. Thank you for watching and see you next time.